Draw the line bond structure of the following molecule. 3S, 6S, 6-isopropyl 3-methyldecane. So today we will learn how to draw molecules and also how to draw the correct chiral centers with the correct configuration on your molecule if it's inside the name. The first thing that we'll do is we will look at the end of the molecule that will tell us the parent chain. Decane, dec means 10, so that means I have a 10 carbon chain, and I'm just going to draw a big chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, a 10 carbon chain. Next, I'm going to add all of the groups that are attached to it. On carbon 3, I have a methyl group. A methyl group is just one carbon, so I'm going to attach it to carbon 3. On carbon 6, I have an isopropyl group, and you just have to remember what an isopropyl group looks like. It looks like letter V. So it's 3 carbons, that's why it's propyl, and isopropyl means it's attached through the middle carbon. My molecule is almost ready, but the most important part is to draw the correct configuration on carbon 3 and carbon 6. What I'm going to do is I'm going to put my methyl group on a wedge in carbon 3, and I'm going to add a hydrogen to this carbon. Notice this carbon has only 3 bonds. Every carbon wants to have 4 bonds, and hydrogens on carbons in the line angle structures are not shown. So if it wants to have 4 bonds and it has 3, it's missing a hydrogen, and the hydrogen will be on a dash because my methyl group is on a wedge. I'm doing it to make my life easier. I will tell you why soon. Next, what we have to do is, first I'm going to erase my numbers because they might confuse me. So let's go ahead and erase all the numbers. And next, what I'm going to do is I'm going to assign priorities to the 4 groups attached to my chiral center. I will assign priorities from 1 to 4, where 1 is the biggest and 4 is the smallest. To assign these priorities, I will use atomic numbers of the elements found on the periodic table. So let's get started. This is my chiral carbon, this is carbon 3, and attached to it I have a carbon, a carbon, a carbon, and a hydrogen. Hydrogen is the smallest on the periodic table. It will get number 4. This carbon is attached to one more carbon. This carbon is attached to one more carbon. This carbon is only attached to hydrogens. This is smaller, gets number 3. Between these 2 carbons, the second carbon is attached to hydrogens only, but this carbon continues the chain and we see another carbon attached to it, 1 and 2. Next, I'm going to connect 1 through 3 and see in which direction it's going. If it's going this way, clockwise, to the right is R. If it's going the opposite way, counterclockwise, to the left is S. I'm going to go ahead and connect 1, 2, 3, and it looks like it's going in the counterclockwise direction, so this is S. Because my group number 4 is on a dash, I do not need to worry about switching anything. That's why I put it on a dash. And I can see that in my name this is S indeed, so I leave it alone. If I needed R instead of S, I would switch methyl and hydrogen. So I would put hydrogen on the wedge and methyl group on a dash, and that's all that's needed here. But I did not need to do that. And let's go ahead and go to the next carbon, carbon 6, 1, 2, 3, 4, 5, 6. This is the carbon, and I will do the same thing. I'm going to put the attached group, in this case isopropyl, on a wedge, and the hydrogen it's attached to on a dash. And again, I'm going to go atom by atom until I find a difference. So this is a hydrogen, carbon. So this is my chiral carbon. It's attached to a hydrogen, a carbon, and a carbon. Hydrogen loses, number 4. The carbon on top is attached to 2 carbons. To the left is only 1, and to the right this carbon is attached to only 1. So this wins. This is number 1. Between these two, let's go carbon, carbon, no difference. Carbon, carbon, no difference. Carbon, carbon, no difference yet again. We have to keep on going. Carbon on the left is attached to 2 carbons. Carbon on the right is attached to only 1 carbon. So this wins. This is number 2 and this is number 3. Let's go ahead and erase just so we're not confused what everything looks like. Make our work very clean. And we connect 1, 2, 3, 1, 2, 3, and it looks like it's going in the counterclockwise direction, which is S. So again, to my lock, I do not have to switch anything because it says that I need S configuration on this carbon. If I needed R, all I would do is I would switch hydrogen and my group. So I would put hydrogen on a wedge and my group on a dash.